So I'm going over the quiz questions from quiz number 2. So looking at the first question gives us a rational function, and it asks us to find all values of x that are not in the domain of h. So domain are the values that are in the domain are the values that you can plug in that give you a real number. So there's really only two major things that can cause us to not have a real number. Taking the square root of a negative number, which we know gives us an imaginary number, or dividing by 0, which is undefined. So anytime you're trying to find the values that are in the domain or not in the domain, we're really looking for those two main things. So looking at the function I'm not given a square root or a fourth root, any even root, so I don't have to worry about that. But I do have a fraction, which means that I could divide by 0. So I need to figure out what would I plug in for x that would make the bottom 0. Well, let's see. If I took the bottom and I want to know what makes it equal to 0, I'm going to set it equal to 0 and solve. And now we have a quadratic equation. So you could solve this by completing the square, quadratic formula, or factoring. This one does factor pretty nicely. 2 times 3 is 6, and 2 plus 3 is 5. So this factors into x plus 2, and x plus 3 is equal to 0. So now I have it in factored form. I'll set each factor equal to 0 and solve. So I get x equals -2 and x equals -3. These are the values that are not in the domain of h. So these are your answers. Your problem may have been a little bit different, but it worked exactly the same way. You were given a rational function. I need to set the denominator equal to 0, and that will tell me where it's undefined, the values that are not in the domain. All right, so looking at the second question, scoop this up real quick. It says to find the y and x-intercept of the line, do not write your answers as ordered pairs. This bothers me a little bit, but this is what Alex asks you for. I prefer to write them as ordered pairs, but we have to follow instructions. So real quick, we know this is a linear function, so whatever it looks like, it's going to be a line, right? Here's my x-axis, here's my y-axis, here is my x-intercept, and here is my y-intercept. So real quick, things that we know, whatever this value is right here on the x-axis, I know one thing for sure every time. The y value is going to be 0. So this coordinate, if we were to write it as a coordinate, would be whatever the x value is, comma, 0. And that's true for every x-intercept. Now, knowing that the y value for every x-intercept is going to be 0, we can use that to figure out what the x-intercept is. So if I want to know what the x-intercept of any function is, I'm going to take the y and plug in 0 for it, and then just solve for x. So for the x-intercept, I plug in 0 for y and then solve for x. So I'm going to do the same exact thing here. I'm going to plug in 0 for y, so I get -5x plus 6 times 0 equals 9. 6 times 0 we know is 0, so I get -5x is equal to 9. Divide both sides by -5. One of the very first sections we did was solving linear equations, which is just what we're doing. So divide both sides by -5, and I get x is equal to -9/5. 9 and 5 don't have any common factors, so this is in simplest form. So what Alex would want is this right here, -9/5. It asks you specifically not to write it as a coordinate. I disagree with that, but we have to follow what the directions are. If we were to write it as a coordinate, it'd be -9/5, 0. All right, so the y-intercept now, essentially the same thing. Anytime you're on the y-axis, you didn't go left or right, so your x value will always be 0. So for every y-intercept, your x value will be 0. And again, we will use that fact to find the y-intercepts. To find the y-intercept, x will always be 0. So we'll plug in 0 for x to find what that y value is. And then we will solve for y. I'm running out of room, but that's okay. I'm going to plug in 0 for x. -5 times 0 is 0. So this value is just going to become 0, and 0 plus anything is just that value. So I'm going to end up, after I plug in 0 for x, -5 times 0 plus 6y equals 9. Negative 5 times 0, like I said, that's 0, plus 6y is just 6y, so we're left with 6y equals 9. This is just a linear equation, so I will divide both sides by 6. So I end up with y is equal to 9 over 6, but they want it in simplest form, as reduced as we can get it. 9 and 6 are both divisible by 3, so I get 3 over 2. So this is what Alex is wanting from you. Okay. So, moral of the story here, no matter what function you are dealing with, in this case we had linear, but that's alright. This is going to work for the quadratics, the cubics, the square root, the rational, the exponential, the logarithmic. Anytime you're trying to find intercepts, if you want the x-intercept, plug in 0 for y and solve for x. If you want the y-intercept, plug in 0 for x and solve for y. Alright, so moving on, question number 3. So question number 3 is asking for the average rate of change. So this is a cubic. I don't know exactly what it looks like, except that it's flipped over. Maybe something like this. Boop. And they want to know what the average rate of change is from -2 to 3. So real quick on a graph, you don't have to graph this to know this, but let's say -2 gives me a point right there, and +3 gives me a point right there. We're just pretending I don't really know what this looks like, but that's okay. The average rate of change is the slope between those 2 points. And we've looked at the linear functions. We know how to find slope. Remember, slope is y2 minus y1 over x2 minus x1. They give you what the x values are. You just need to find the y values using the function. So when x is -2, what's the y value that goes with it? Well, let me plug it in. H of -2 is equal to -2 times -2 cubed plus 3 times -2 squared. And I am going to put that into my handy dandy calculator so I don't screw up any of the values. I get 28. And then I also need to know the other y value. So what does this function equal when x is 3? So I'm going to figure out what is h of 3. Well, let's see. I get -2 times 3 cubed plus 3 times 3 squared. Again, handy dandy calculator. I get -27. So I have y values and I have x values. So essentially I have coordinates. When x is -2, y is 28. So I have -2, 28. And when x is 3, I get -27. So I have 3, -27. If that's easier for you to find slope from 2 points. I'm just finding slope. That's what the average rate of change is. So let's go ahead and plug it in. I'll let -2, 28 be my x2, y2, but it doesn't matter. So I have 28 over -2 minus, that's part of my formula, and then -27 over 3. So a negative and a negative touching become a positive, so I get 55 over -2 minus 3 is -5, which gives me -11. Now, of course, my picture was off. This gives me a positive slope. We ended up with a negative slope. But there we go, finding the average rate of change. All right, so number 4. A line passes through the point -4, -3, and has a slope of 32. Write an equation in slope-intercept form for this line. So slope-intercept form, remember, is y equals mx plus b, where m is the slope and b is the y-intercept, hence the name slope-intercept form. Now, there's many different ways that I can come up with this equation given the point and the slope. We could use point-slope formula, we can use slope-intercept formula, or form of the line. Since they're asking for the equation specifically in slope-intercept form, I'm going to use slope-intercept form. So we have y equals mx plus b. Again, m is slope, and they give me slope. So right now, I already know y equals 3 over 2x plus b. You're halfway there. The only other thing that I need to know is what my y-intercept is. I have three variables here. I have a y, I have an x, and I have a b. B is my y-intercept. Do I have an x or a y that I could plug in? If I could plug in values for two of these three variables, I could solve for the remaining variable, right? Well, that's where the point comes in. Remember, a point is an x value and a y value. So yes, I have an x value and a y value. I will plug these numbers in and solve for my y-intercept. So x is -4, so I get 3 over 2 times -4. And y is -3. So now, again, I have a linear equation, and I just need to solve it for b. So 3/2 times -4, 3 times -4 is -12, divided by 2 is -6. So I get -3 equals -6 plus b. Solving the linear equation, so I need to get b all by itself. So I'm going to add 6 to both sides. -3 plus 6 is 3. So I get that my y-intercept is 3, b is 3. So to write the equation, or an equation, of this line in slope-intercept form, again, I need slope and I need the y-intercept. I was given the slope, I found the y-intercept, so I'm just going to plug them in. I have y equals the slope, which is 3 over 2x, plus my y-intercept, which is 3. There we go. Equation of the line in slope-intercept form. Alright, so the last one, we need to identify the center and the radius, and then graph the circle. So we're given the equation in general form, we want to write it in standard form. Remember, with the circle, your squared values, x squared and y squared, need to have a coefficient of 1. They both have a coefficient of 2, so I'm going to start off dividing everything by 2. So that gives me x squared minus 6x plus y squared plus 5y equals 3 over 4. I divided everything by 2. And now I'm going to do it the shortcut way. If you need a little bit more than that, you need to go back and watch the Completing the Square videos posted in Blackboard, and the writing the equation of a circle in standard form videos. So grouping my x's, taking half of that value, I get x minus 3 squared. Likewise with my y's, taking half of that value, so 5 over 2 squared equals, I'm going to bring down my 3/4. Now, in order to complete that square, what I actually did was add in this value squared. So 3 squared gives me 9. I added it to the left. I need to add it to the right. Likewise here, I'm adding in that value squared. So 5 over 2 squared is 25 over 4. I added it to the left. I need to add it to the right. So I have x minus 3 squared plus y plus 5 over 2 squared equals, handy dandy calculator, I get 16. Alright, so this is the equation of the circle in standard form. What's nice about standard form is I can pull out my center. The center is h and k, so the opposite of these values. So if this is -3, my center is going to be +3, -5 over 2. And my radius is, this is my radius squared, right? So if it's 16, the square root of that gives me 4. So here's my center, here's my radius. I want to graph that now. So I'll plot my point, my center. I have 1, 2, 3, and -2.5, so about right here. And then my radius is 4, so that means in all directions I'm going out 4. So I'm going to go up 4, down 4, left 4, right 4 to get a general outline of my circle. I think in ALEKS, all you have to do is plot one point, so you could pick any direction to go out for that radius, and then you just click the circle button, and there you go. So I'm going to 1, 2, 3, 4, somewhere, I don't know. We're just gonna BS this real quick. Going out 4 in all directions. My circles always come out as footballs anyways. Pretend that's a circle. Ooh, that's so bad, but that's okay. You get the idea.